Hi everyone, good to have you. This is E Plus Academic Resource Center, where we take online tutorials for undergraduates and senior secondary students. So today we are going to be looking at statistical tests for hypothesis. This is the full class, okay? All right, so now when we say hypothesis tests, what do we mean? Hypothesis is simply a statement, okay? A statement about the probability distribution of what? Of the population. It's just a statement about the probability distribution of what? The population. Okay? Now, hypothesis testing helps us to draw conclusion about an unknown parameter of the population. Okay? It helps us to draw conclusion. Now, in a layman language, let me use it this way for you to understand it better. In our everyday life, we are faced with decisions. Okay, we are faced with circumstances or situations that warrant us to make critical decisions. Okay. Now, to help us make a good decision, we come up with what we call assumptions, okay? Those assumptions can be referred to as the hypothesis in this case, okay? Now, to help us make a good decision, we test those assumptions and see the one that best fits or the one that is in proper consonance with the situation, okay? So when we put those assumptions to test, that is what we refer to as the word hypothesis testing or hypothesis test. Do you understand? So basically, in a nutshell, hypothesis test is just about drawing conclusion, okay, about something or about situations, about circumstances, about a population, okay? All right. So now, in this case now, we are narrowing it down to population, okay? So we are trying to draw, we take samples from the population. The population is large, is big and all that, but we draw out samples and we carry out tests on those samples that will give us information about the population. Do you understand it? Let's proceed. Now, when we talk about hypothesis testing, we have two types of hypothesis tests, okay? We have number one, we have what we call the null hypothesis, okay? The null hypothesis and the alternative hypothesis, okay? The alternative hypothesis, okay? Now, the null hypothesis is the hypothesis being tested, okay? It usually states in the form of no difference, okay? When we say something is equal to something, that we are saying no difference in that, okay? Something is equal to something. Students in SS2A are equally brilliant with students in SS2B. Okay, so there is no difference here. So we're talking about the null hypothesis here. Okay, it is the hypothesis being tested. While the alternative hypothesis is the opposite. It's usually stated in the form of a difference. Students in JS2A they are more brilliant or they are not equally brilliant with students in SS2B. Students in SS2A are more brilliant or they are not equally brilliant with students in SS2B. That is the alternative hypothesis. So it is stated in the form of a difference. We are trying to say there's a difference. This one we are saying no difference. This one we are saying there's a difference. So the null hypothesis is the hypothesis being tested. Are we together? All right. Then the hypothesis here being tested can be directional, okay? Can be directional or non-directional. Are we together? It can be directional or non-directional. Okay? Are we together? Please use the comment section. I'm going to be as slow as possible so that you can get me. I will always come back to, repeat myself. So calm down, take it easy, use the comment section if you don't understand so that we'll get along. Are we together? So now, it is directional if we talk about more, less than, or greater than. If we talk about more or less, okay, then it is non-directional if we talk about no difference. I'll give an example. Now, if we say, okay, let our null hypothesis be equal to students in just 2A, 2A, okay, they are equally brilliant with students in 2b. Okay? Now, for directional hypothesis now, we are saying students in, sorry, this is the null hypothesis. Now, before I continue, the alternate null hypothesis is usually stated in HO, while the alternative is H1. Okay? Is denoted by HO, while the alternative hypothesis is denoted by H1. So now we are saying that I'm trying to differentiate between directional and non-directional for you. Okay? We say directional is when the statement goes like more than, less than, okay? Or for non-directional, when it states that there is no difference. This is a sign of there is no difference, okay? Now, for directional, if, for instance, our null hypothesis is stated that students in 2A are equally brilliant with students in 2B, the alternative under directional now will be students in 2A are more brilliant than students in what? 2B. Or students in 2A are less brilliant than students in 2B. So when we have a case like this, it is what? Known as a directional what? Hypothesis. Do you get it? It is known as a directional hypothesis. Now, for non-directional, we have something like this. Students in 2A are equally brilliant with students in 2B. Then students in 2A, for the alternative hypothesis will be students in 2A, students in 2A are not equally brilliant with students in 2B. Can you spot the difference now? So, the alternative hypothesis here helps us to understand whether our hypothesis here is a directional or a non-directional hypothesis. Okay, so here we have greater than or less than, but here we have not equal to. Okay, so when your assumptions on your hypothesis or what you're trying to carry out a test on states that your states whether more than or greater than or less than or stuff like that, you're talking about a directional hypothesis. So, but when your information talks about not equal to, okay, we are talking about what? A non-directional hypothesis. So we are going to look at some examples later on, but now let's just stay with me. Just let's understand the basics, okay? Okay. Now, there's what we call the simple or the composite hypothesis, okay? Let me use this pattern. We have what we call the simple or composite what? Hypothesis. The simple or composite hypothesis. The simple or the composite hypothesis. We are going to see the meaning now. A hypothesis is simple if it completely specifies the value. If the values are specific. If it completely specifies the value. This is what we mean. If we say x equal to 70% or x equal to 0.7, take note of the sign here. When we have situations like this, okay, we say that hypothesis is simple. It's straight to the point. S equal to. But when we say composite hypothesis here, we are talking about when it is not specified. Okay, when it is not specified. When the values are not specified. That is, we may have x greater than 70%. So here now, it can be 70%, it can be 80%, it can be 90%, it can be 71%, it can be 72, 73, and like that. It's not specific. Or s less than 0.2. In this case now, it can be 0.1, it can be 0.001, it can be 0.002, like that. It is not specific. But here now, the simple hypothesis, we have s equal to 70%. It's 70%, nothing more, nothing less. Here, x equal to 0.7 is 0.7, nothing more, nothing less. Do you get it? So, but in this case, in the composite hypothesis here, it is not specific. They're telling us it can be this one, it can be this, it can be this, it can be this number, it can be this number. Do you get the difference now? Yes, that is the difference between composite and simple hypothesis. While, let me come back to the directional. Directional here, it is directional when it is what? When when it states that there is greater or less, when it states that there is less or greater or more, stuff like that. But under non-directional, it's when it states that there is no difference. Do you get it? All right. So having known that, we are going to be looking at, please use the comment section if you don't understand what we're talking about, or you're confused, or you want to add something. Use the comment section. So now we're going to be looking at the types of error, okay? Types of error, okay? Now we have what we call the type 1 error. We have the type 2 error, okay? Now, the type 1 error here means, rejecting the null hypothesis, which is actually true. When a statistician rejects the null hypothesis, which is actually true, which should have been accepted actually. When a statistician rejects the null hypothesis, when it's actually true, he has committed a type 1 error. While when he accepts the null hypothesis, when it is false, which should actually been rejected, he has committed type 2 error. This is what we mean. Rejecting the null hypothesis when it is true, okay? When it is true, which should have been what? Have been accepted. When a statistician rejects the null hypothesis when it is true, which should have been accepted, he has committed type 1 error. Then the opposite of it, which is accepting what? Accepting the null hypothesis. Okay? Accepting the null hypothesis when it is actually false. When it is actually false. Okay? Which should have been what? Which should have been what? Rejected. Which should have been what? Rejected. And all that. Which should have been rejected. Then he has committed a type 2 error. Do you get the difference? For instance, let me give an example. When a judge sets a criminal free. Now, this criminal actually committed a crime. Okay? When a judge sets him free. Okay? Now, the null hypothesis would be that the criminal is guilty. Criminal is guilty. Okay? Then the alternative would be that criminal is not guilty. Okay? Now, we are trying to carry out a test or judge this case based on the null hypothesis that this criminal is guilty. But when a judge sets him free after all evidences, he has committed a type 1 error. He has actually rejected the null hypothesis when it is true. Okay? Which should have been what? Accepted, that this criminal is guilty. But the judge sets him free. So he has committed the what? The type 1 error. Do you get it now? That's the difference. So now, this leads us to what we call the what? Size of error. This leads us to what we call size of error. And we are going to know what that is all about. Are we together? Use the comment section if you don't understand. Let me explain them more. So, now, when we say size of error, it is the probability, okay? Probability that the error is made. The probability that the error is made. That's what we refer to as size of error, okay? So, size of type 1 error, okay, is the probability that type 1 error is made. is the probability that type 1 error is made. That is rejecting the null hypothesis when it is actually true. So that is the size of type 1 error, the probability that type 1 error is made. Do you get it? And the type 1 error is usually denoted by alpha, what we call a Greek alphabet known as alpha. Okay? Also known as the level of what? Significance. Significance. Level of significance. Okay? And it's usually between 0 and 1. So the commonly used level of significance here is what? 5%, which is equal to 0.05, or 1%, which is equal to 0.01. Okay? So these are the common level being used in statistics. 5% and or 1%, which is 0.01. Okay? So the probability that type 1 error is made is what we call the level of significance, and it's denoted by A. Okay? This alpha, Greek letter alpha. Are we together? Then for type 2 error, okay? For type 2 error, the size of type 2 error is the probability, okay, that type 2 error is made. Are we together? Is the probability that type 2 error is made. That is accepting the null hypothesis when it is actually false. Okay? Accepting the null hypothesis. That is the size of error. Accepting the null hypothesis, when it is actually false. When it is actually false. Okay? That is the type 2 error. That is the statistician has committed the type 2 error. And the probability of the type 2 error is the probability that type 2 error is made. Okay? Are we together? So, the type 2 error, alright? So, the probability that the type 2 error is made, which is accepting the null hypothesis when it is actually false. Now, the probability of the type 2 error, okay? Probability of type 2 error is denoted by what? The letter beta, the Greek letter beta. Okay, so the complement of beta, we have 1 minus b, okay? Which is equal to what we call the power of the test. Power of the test, okay? Now, the power of the test is simply the probability of what? The probability of rejecting a false null hypothesis. That is the probability of the test. The probability of rejecting a false null hypothesis, that is the power of the test, sorry. Okay, so the probability of the type 2 error is denoted by the letter beta. So the complement of the probability of type 2 error is known as 1 minus b. Same thing with level of significance, because we're talking about probability here. So the type 1 error, okay, lies between 1 minus what? It's the probability of the type 1 error is given as 1 minus alpha, okay, and it lies between 0 and 1, since it's a probability, okay. And we know we mentioned that earlier when we did the probability of type 1 error. So since it's lies between 0 and 1, that's why we have 5% here, which is equal to 0.05, and 1% here, which is equal to 0.01. So if you check, these values lies between 0 and 1. Okay, so the probability of type 1 error is given as 1 minus a, and the probability of the type 2 error is given as 1 minus beta, which is also known as power of the test. This one is known as the power of the test, while for that of type 1 error is known as the level of significance. Okay, now we say power of the test, we are trying to say that the probability of rejecting a false null hypothesis is referred to as the power of the test. Are we together? Use the comment section, ask me a question where you don't understand, so that we can be on the same page. Alright, so here is what's going to happen. I'm going to stop here. So we're going to have the part 2 of this class in the next class, okay? Let me not make it too long, and let me not rush you, so that you can be able to digest it and ask your questions. Are we together? Alright, bye-bye for now.